Okay, so this is the chapter 2 through 5 review. And so this first problem, the goal of it is to see if you know the difference between the quantitative and categorical. Okay, so they give you these things. Age, since age would be a numerical amount, it's going to be quantitative. Okay, so all of your answer choices have that. Amount contributed monthly, that would be in a money amount, so that will also be quantitative. So A and B are fine, C is fine, D is not okay because D says that amount contributed is categorical, so that's out. And so there you go. All right, next, type of contribution. So type of contribution, whether it's 401k, Roth, so that type is a category. So that means that our last one, type, is categorical, and that's here. So B looks good. A does say it's quantitative, so that's not good. C says type of contribution, and then it talks about something else. We don't have something else. And E says that it is a quantitative, but it also says that we have something else. So B is the answer. 2, similar idea. We have the mother's age. That's a numerical value, so that would be quantitative. Pregnancy weight would be quantitative because that's a numerical amount. Level of prenatal care. Now look at how they describe this. None, minimal, or adequate. So that level of prenatal care will be categorical. And then if they used drugs during pregnancy and what they were, cigarettes, alcohol, etc., that means that will be categorical also. Okay, so you can see E had the pregnancy weight wrong. B had the mother's drug use as quantities, and that's wrong. And then this one didn't have enough information. A also did not, so D is the right answer. Okay, which one of these is categorical? So on this next one, SPCA. So this would be a number value, that's quantitative. Weight would be a number value, that's quantitative. Age and money, those would all be quantities in numerical values. Breed is a category, such as Golden Retriever, Pug, Jack Russell, all that kind of stuff. Okay. All right, next. So I figured this out, and because that we needed other, because I noticed in the picture options that other was in some of the picture options that we had, such, down here is other. So I apparently needed to figure out how much the other was. So I came up here and I added all of these up, and they added to 70, I guess. So other has got to be 30%. So then I started looking at the pictures, and with number 2, it did not have the other category. So this one, since picture 2 did not have the other, it's out. So we're down to picture 1 or picture 3. And I'm going to tell you what happened here. This cancer area bothered me because the cancer area is supposed to be, look, it's actually pretty close to the heart disease size. But if you take a look at what we got right here, it looks a lot smaller. In fact, one could argue that it looks smaller than this respiratory disease. Okay, so, and it's obviously not smaller than respiratory disease or even the same size. It looks too close. So this cancer area is way out of whack when it comes to the size of it. So that violates the area principle. So, therefore, 1 is the best picture, and so 1D is the answer. All right, next section. So what I notice whenever we have all these numbers here is that, these percents are definitely way more than 100% total. So we must have overlap. We must have some people that are in more than one type of activity. So I'm going to take that into account when I'm looking at my options down here. Now, when I look at this first picture, one thing that I see is that, for example, going from swimming to aerobics. Let's just compare those. I mean, in my idea, in my mind, you got this is just this size. Well, that's about that big. Okay, so aerobics looks so much, it looks 3 to 4 times or more bigger than swimming. And so if I look back up here at the answer choices, though, aerobics is not even twice as big as swimming. But yet, this picture here makes it look so much, very much bigger, at least 3 times bigger than swimming. So that is a violation of the area principle. So 1 is out. Number 2, when I looked at these amounts and I compared all of those looked adequate. So at first glance, I think that's okay. So I'm going to go ahead and go on to the next one, check that one out. So when I look here and I look at the options, well, first of all, I know that there has to be overlap, and a pie chart does not allow for overlap. When you have a pie chart, you cannot have overlap. You can have no overlap, and there's supposed to be. So that's why 3 doesn't work. So by default, the only one that works is 2. So the answer is D. All right. Next, number 6. So now we're getting into this marginal and conditional stuff, or just figuring out percentages that it asks. So here we go. With this first one, what percent of the class, okay, once you hit this verb, considers, once you hit that verb, you now are talking about the numerator, okay? So this over here is the denominator. So the class, the entire class is the denominator. And the numerator will be liberals. Consider themselves to be liberals. So it's just all the liberals. So that's how we have 81 out of 184, which is 44%. All right, next, we have the use of these words marginal, and then we have conditional in number 8. So let's take a look at that. All right, so remember on these types of problems, you ask yourself, what's the explanatory? What's explaining what? Driver is explaining origin of car. So I can tell that since driver is explaining, that's where my fractions are coming from. So my fractions are going to be going in this direction. Okay? Because driver is the explanatory variable. So they go top to bottom. All right. So it says marginal. And marginal comes from the margins. That is the edges. This section here, student and staff, are the conditional. And this out here, all by itself here, is marginal. Okay? So that means I should be having American is 194 over 391. European is 62 over 391. And Asian is 135 over 391. So those percentages that come out properly, and they obviously rounded to a whole number, is D. All right, number 8. Number 8 says, what are the conditional? So we have the same data. It does want conditional. Remember, this is the conditional section, and out in the margins is the marginal. It wants conditional for students. So it wants this section here. So because it wants that section, I had to find the total for students and then make my fractions this direction. So American in the student category is 92 out of 199, European 38 out of 199, and Asian 69 over 199. So that's the conditional student section. And there are your numbers. Okay, moving on. So this one is interesting. The idea that this one was getting to is trying to put a problem in here that referenced Simpsons Paradox, okay? So that was the idea of putting a problem like this in. So let's talk about Simpsons Paradox again. So with Simpsons Paradox, the conclusion you get from the separate groups is different when combined. Okay, so the conclusion you get from the separate groups is different when combined. Okay, so let's look at the conclusion we get from the separate groups. So when we look at this company, Fast Packs, versus this company, Super Ships, okay? So they split them. They separated into, are we talking regular or overnight? Regular or overnight. So what I want to do is compare the regular Super Ships to the regular Fast Pack. So I want to compare these numbers together. Okay, and then we're talking about the percent late. Well, which company did worse? Since Fast Packs has a higher percentage that is late, Fast Pack is worse for regular. Okay, now let's look at overnight packages. Let's compare overnight packages on Super Ships to overnight packages on Fast Packs. So here we go. So here is overnight Super Ships. That's 10% of the packages were late. I got that from 50 over 500. On Fast Packs, 32 out of 200, 16%. So you are comparing this 10% to this 16%. Obviously, Fast Packs is worse overall. Or, I'm sorry, worse for the overnight. So regular package, Fast Pack is worse. Overnight package, Fast Pack is worse. But let's look overall. Overall, Super Ships has 54 out of 700 late, and Fast Packs has 47 out of 700 late. So if you looked overall, who looked to have more late? Well, more late was Super Ships. So if you looked overall, Super Ship looks worse, but if you look with the separate groups, Fast Packs is worse. So the conclusion we got from the separate groups is different conclusion that we got from them being combined. Okay, so obviously we should not combine them together because that changes the result. And remember, it does that because we added the packages wrong. So it just really took analyzing this data. A is the one that has the percentages correct. So you had to just get to the nitty-gritty and read very carefully as to what all of those said. E does say something about Simpsons Paradox, so I was tempted. Let's look at what E says. E says, No, this is an example of Simpsons Paradox and unfair averaging. Okay, I like that. That's a good sentence. Since the overall percentages and individual percentages disagree on which delivery service is better. Okay, that's great. That is true. Individual percentages said Fast Packs was worse, and the overall percentages said Super Ships is worse. Okay, so that's true. Now, this is what I don't like. This is where it starts getting weird. It says both services can be considered equal. No. That says since one's worth one way and one's worse the other way, both of them can be considered equal. It cannot be determined whether Super Ships or Fast Packs delivers on time more often. No, that's not true. I mean, you have to use your common sense and know that separately is a better, listing them separately is fine. There's obviously different things going on during regular service and overnight. So the separate is the way to test them out. So that's why E is not correct. Okay, moving on. All right, here was another problem that attempted to consider this idea of Simpsons Paradox. So what I did was we looked at the overall acceptance rate. Okay, so overall, 49% of male applicants were accepted and 37% of female applicants were accepted. So overall, it looks like more males are accepted. Okay, but we saw something like this similar when we did our notes. And at universities, they looked at then the programs separately. So when we look at these programs separately, let's look and see. So in program number 1, and I went ahead and figured out the percentages. 429 out of 692, 62% of the males, 84% of the females. So who was better? Females. In program 2, 63% of the males, 78% of the females. So who was better? Females. In program 3, 34% of the males, 37% of the females. So who was better? Females. And the last one, in program 4, 6% of the males were admitted, 9% of the females were admitted. Who was better? Females. So what happened was, in every category, when you looked at them individually, females had a higher admittance rate. Okay, so obviously, overall, combined these fractions incorrectly. It totaled them across categories that should not have been totaled. They should have been kept separate. They were not totaled correctly. So that gave this, so then you just read all the answers, and D ended up being the correct answer on that one. Okay, and now we go to the idea of the box plots that we learned yesterday. So here we go. This one, the answer was 2. So what I did on this was I put all of this into my calculator. Okay, and you put that into list 1 in your calculator. And remember, you calculate, you go stats, over to calc, 1 variable stats. Okay, and then scroll down, and that's how it gives you the 5-number summary. So there they are. Okay, now, do you remember what IQR is? Q3 minus Q1, so that's how I got that number 24. So I'm telling you that on these problems, on the test, even though it's multiple choice, you have to do all of the work just as if you are doing them from scratch. There's no way to know these answers without actually getting to the nitty-gritty and computing them. So here on this, I did this out, and then I figured out the upper fence. So that is Q3 upper outlier fence. It is Q3 plus 1.5 IQRs, Q3 plus 1.5 IQRs. So that upper fence is at 115. So if I think about that upper fence at 115, look at the highest number, 99. Are there any outliers above 115? And that answer is no. So therefore, my conclusion is no upper outliers. So then I can mark off this answer here because there's no upper outliers. So see, you have to compute the fences to see if there are outliers. So I go to the lower outlier fence. It is Q1 minus 1.5 IQRs. Q1 minus 1.5 IQRs. That came out to 19.5. So I'm going to come up here to my data. 19.5 is below 32. So there is no data below 19.5. So there will be no lower outlier. Okay? Besides that, you also were plotting these 5-number summaries on the chart. This one had a wrong median, this one had a wrong median, and the other ones had the wrong outliers. So therefore, B is the answer, or 2. Okay, then you do that same process again. So again, I put all of this data into my calculator, into list 1, and I did stat, calc, 1 variable stats, and I got this 5-number summary. So you have to do that 5-number summary, and then of course I did the IQR by doing the Q3 minus Q1, and I got that 5-number summary. Okay, so then you have to do these fences, okay? You cannot get past these just because they are multiple choice. You cannot get past doing the computing. You have to do it. So I do the upper fence. It is Q3 plus 1.5 IQRs. Q3 plus 1.5 IQRs. That brings it to 2297. So when I look at 2297, look at my data up here at the top. 2297 falls here. Luckily, the data is in order. So 2297 falls right here in between 1720 and 2500. So guess what? I know these two numbers, 2500 and 3700, are outliers. So I know right now there are 2 outliers. And because of that, I can knock off all of the answer choices that do not have the 2 outliers. Okay? So I am now to 2 or 3. They don't have lower outliers, and I could have figured that out from my fence. But then look at the difference between these two, where the median is located. Is the median located above 1,000 or below 1,000? The median is 705, so this one has a wrong median. Okay? So you're just getting to the nitty-gritty of exactly where those items are located. All right, moving up here. Okay, so, and I do not know why students miss these. I remember students miss these on the test, and they're pretty straightforward. So you have got to get these kinds of problems. They're just straight computing, mathematical computing. And so let's go through it. You cannot miss these on the test. They should be just gimme problems. So I put this into my calculator, and I got my 5-number summary. And so since we are looking to see about outliers, then I got my numbers, and I figured out the upper fence and the lower fence. So after putting it in my calculator, 1 variable stats, getting my numbers, it is Q3 plus 1.5 IQRs. So upper fence is 107.5. So if the upper fence is 107.5, it is here above 99. So there is no upper outliers. All right. Now lower outlier fence, it is Q1 minus 1.5 IQRs. That's 39.5. So Let's look at the list of numbers. 39.5 is right here between 35 and 37. So 35 is below the lower outlier fence, so it's a lower outlier. So 35 is the outlier, only outlier in this data set. 14 is done the same way. You have to go put these in and go put them in the calculator and find your 5-number summary. When you do that, I do my upper fence. And then to get your IQR, you got to do your Q3 minus Q1. So upper fence is Q3 plus 1.5 IQRs, Q3 plus 1.5 IQRs. So my upper fence is 31.7. So I am thinking in my brain, are there any numbers above 31.5? Any numbers above 31.5? So I'm looking. Oh, 32 is above 31.5. I'm looking through these numbers, and lo and behold, 37 is also above 31.5. So there's 2 of them. Okay, so I'm looking at, that's a possibility, C is out, D is out, and I know and E is out. So I'm down to A and B. So I need to know, is there a lower outlier? So I'm going to make my lower outlier fence. It is Q1 minus 1.5 IQRs, Q1 minus 1.5 IQRs. Well, that is 3.5. So anything below the lower fence or above the upper fence, below the lower, above the upper. So I'm looking, is there any numbers below 3.5? And ta-da, there's a 1. So 1 is also an outlier. B has 3 outliers. All right, so there's several answers I could see for this 15. But let's go through some things on it. So it just kind of gives this opinion of, is this economy priced? I don't know if there's one like this on there. Well, there is no free response on the test. I think it's all multiple choice. So it would be giving you options that you could go through to see. I wanted to point out a couple of things on this computer printout. Here is your minimum, Q1, median, Q3, and maximum. We will not ever use this mid-range. We do not use mean for this problem. We will use mean later in this class, but not for our box plots. This trimmed mean we will actually never ever use, and then this is standard deviation we'll use later. So you're only going to be using this 5-number summary information, okay? All right. So 31.5 is considered, they call it economy priced. So you have to support if you think that is considered very low. So my first thought was, it would be very low if it's a lower outlier. So that's the first thing that came to my mind. I don't know what their answer choices would have been if this was a multiple choice, but that was the first thing that came. To my mind, is it a lower outlier? So I computed. So I said, I got my IQR. I did. It is Q1 minus 1.5 IQRs, Q1 minus 1.5 IQRs. And that gave me, lo and behold, negative 90. So I'm pretty sure there's nothing below negative 90. So we have no lower outlier possible because that fence is at negative 90. So that's kind of out of the question. So then I got to thinking. Let's think about this, okay? Think about a box plot. So if we have a box plot, this is just a sketch, quick sketch. I'd probably want to do it to scale if I was really making this thing. It looks like it's going to be something like this. So here's your median at 50, which is closer to 30. And then you got 110 all the way out here, and 200. And of course, there may be an upper outlier, I don't know. Okay, so this is just a rough sketch. So if you look at this rough box plot sketch, where is this so-called economy priced item located? Well, this economy priced item is located right here at 31.5 or 95 or whatever that price was. 31.95. Well, where is this in relationship to all the other data? Okay, first of all, it's in the box. If it's in the box, is it rare? Remember this box, the interquartile range, the middle 50%. So if it's in the middle 50%, I'm thinking that it's not unusually low. It's not even in the bottom quarter. Remember that this is the lowest 25%. These are the two mid sections. This is 25% of the data and 25% of the data, and then this is the upper 25% of the data. So 31.95 is not even in the lowest 25%. It's somewhere in the middle 50. So in my mind, right there, in my opinion, I don't think that's considered low. So that's what I wrote here. 31 is above Q1. So it's not even in the lowest quartile. It's above the lowest quartile. I don't think economy priced is being over 25% of the phone costs is going to be considered economy priced. All right. So that's the end of that information. Your test will be 16 multiple choice questions, very similar to these questions here. So you need to understand the format, the wording, how to do your computing on all of these, and then you can do well on this last test in this 6 weeks.